Mazda has always been known as the company that prefers to take the road less traveled. While much of the automotive world rushed toward turbocharging, downsized engines, and now full electrification, Mazda has repeatedly invested in improving the internal combustion engine. Many critics believed that strategy would eventually leave the company behind. Instead, Mazda has continued proving that innovation doesn't always mean abandoning proven technology. Now, with its latest engine developments, the Japanese automaker has once again captured the attention of engineers, competitors, and car enthusiasts around the world. The reason is simple. Mazda isn't just building another gasoline engine, it's combining decades of combustion research with hybrid technology, advanced manufacturing, and smarter combustion techniques to squeeze more efficiency out of every drop of fuel. At a time when emissions regulations are becoming stricter and customers are demanding better fuel economy without sacrificing performance, Mazda's newest powertrain strategy could represent one of the most practical solutions available. The centerpiece of this strategy is Mazda's next-generation Skyactiv-Z engine. Designed to replace the current Skyactiv-G family, the new engine aims to achieve what Mazda calls the ideal combustion. That phrase might sound like marketing language, but behind it lies years of engineering focused on making combustion cleaner, more efficient, and more predictable under every driving condition. Unlike many manufacturers that rely heavily on smaller turbocharged engines, Mazda is refining naturally aspirated technology while integrating sophisticated hybrid systems. This allows the company to maintain smooth power delivery, excellent throttle response, and long-term durability while significantly improving fuel economy and lowering emissions. One of the biggest engineering challenges has always been balancing power and efficiency. Traditionally, improving one meant sacrificing the other. High compression ratios improved efficiency, but increased the risk of engine knock. Rich fuel mixtures generated more power but wasted fuel. Lean mixtures improved economy but became unstable. Mazda's engineers spent years studying combustion behavior inside the cylinder. By redesigning combustion chambers, improving airflow, refining fuel injection timing, and optimizing ignition control, they believe they've come closer than ever to achieving near-perfect combustion across a wider operating range. This doesn't simply improve fuel economy. Better combustion also reduces harmful emissions before exhaust gases even reach the catalytic converter. That means lower environmental impact without relying entirely on expensive after-treatment systems. The Skyactiv-Z engine also builds upon lessons learned from Mazda's revolutionary Skyactiv-X engine. When Skyactiv-X debuted, it introduced spark-controlled compression ignition, or SPCCI. It combined characteristics of both gasoline and diesel engines. Under many driving conditions, the engine compressed a very lean air-fuel mixture until it nearly ignited by compression, while a spark plug precisely controlled the timing. The concept promised diesel-like efficiency while maintaining the smoothness and cleaner emissions of gasoline engines. Although technically impressive, Skyactiv-X proved difficult and expensive to perfect. Instead of abandoning the technology, Mazda used real-world experience to improve future designs. Many of those lessons now feed directly into Skyactiv-Z. Rather than chasing revolutionary complexity, Mazda focused on simplifying combustion while preserving efficiency gains. Engineers redesigned virtually every aspect of the engine to create a power plant that's easier to manufacture, more reliable, and even more efficient. Perhaps the most surprising aspect is Mazda's decision to continue investing billions into combustion engines while many competitors publicly commit to all-electric futures. To some observers, this appeared risky, but Mazda believes global markets will require multiple powertrain solutions for decades to come. Electric vehicles continue growing rapidly, but charging infrastructure, battery costs, raw material availability, and regional energy differences mean gasoline and hybrid vehicles will remain important across many countries. Instead of betting everything on one technology, Mazda is pursuing a multi-solution strategy. Customers will see battery electric vehicles where they make sense, plug-in hybrids for longer distance flexibility, traditional hybrids for maximum efficiency, clean diesel in selected markets, rotary engines serving as range extenders, and now an entirely new generation of gasoline engines. That diversified approach gives Mazda flexibility while reducing dependence on any single technology. The company is also pairing Skyactiv-Z with next-generation hybrid systems developed to maximize efficiency during real-world driving rather than laboratory testing. Modern emissions regulations increasingly focus on actual road conditions instead of ideal testing environments. That requires engines capable of maintaining clean combustion under cold starts, heavy acceleration, highway cruising, and stop-and-go traffic alike. Mazda believes its latest combustion technology allows exactly that. Hybrid assistance further reduces fuel consumption during low-speed driving, where gasoline engines are traditionally least efficient. Electric motors provide immediate torque during acceleration, while allowing the gasoline engine to operate closer to its most efficient range. The result isn't necessarily headline-grabbing horsepower. Instead, drivers receive smoother acceleration, lower fuel bills, quieter operation, and fewer emissions. For millions of consumers, those everyday improvements matter more than achieving sports car acceleration numbers. Another area where Mazda continues to stand apart is engine displacement. Many manufacturers have downsized from 4-cylinder engines to tiny 3-cylinder turbocharged units. While these smaller engines perform impressively on paper, real-world fuel economy sometimes falls short because turbochargers frequently operate under boost during normal driving. Mazda has largely resisted this trend. Its naturally aspirated engines often deliver consistent efficiency without relying heavily on turbocharging. Drivers also appreciate their predictable throttle response and lower mechanical complexity. The new Skyactiv-Z continues this philosophy while integrating improved combustion management rather than simply adding more boost pressure. This reflects Mazda's engineering culture, where elegant solutions often replace brute force approaches. Mazda's innovations extend beyond combustion alone. The company has significantly reduced internal engine friction through improved piston coatings, optimized crankshaft design, lighter moving components, and better lubrication systems. Every tiny efficiency gain contributes to overall fuel economy. Even reducing friction by a few percentage points can save measurable amounts of fuel across millions of vehicles over their lifetimes. Thermal management also plays a major role. Engines waste enormous amounts of energy as heat. Mazda redesigned cooling systems to warm engines faster after startup, while preventing unnecessary heat loss during operation. A properly managed engine reaches optimal efficiency sooner and maintains it more consistently. Cold starts have always represented one of the least efficient periods for gasoline engines. By shortening warm-up times, Mazda improves both fuel economy and emissions. Engine software has also become dramatically more sophisticated. Modern engines contain dozens of sensors constantly monitoring combustion quality, air intake, temperatures, exhaust composition, throttle position, and countless other variables. Mazda's latest control systems process this information in real time, adjusting ignition timing, valve operation, and fuel delivery thousands of times every minute. Instead of relying on fixed engine maps, the software continuously optimizes combustion based on actual driving conditions. Artificial intelligence and machine learning principles are increasingly influencing calibration methods as manufacturers process enormous amounts of engine data during development. Mazda's engineers use advanced simulations that would have been impossible only a decade ago. These digital models allow engineers to analyze airflow, combustion flame propagation, fuel atomization, and heat transfer with extraordinary precision before physical prototypes are even built. That accelerates development while improving reliability. Durability remains another important selling point. Mazda has traditionally earned a reputation for dependable engines capable of lasting hundreds of thousands of miles with proper maintenance. Rather than pushing components to their absolute mechanical limits, Mazda generally favors balanced engineering. That philosophy appears unchanged with Skyactiv-Z. Instead of chasing maximum horsepower, engineers focused on long-term efficiency, lower operating stress, and consistent performance over years of ownership. This approach particularly appeals to buyers planning to keep vehicles for extended periods. Industry analysts are watching closely because Mazda's success could influence other automakers. If Skyactiv-Z delivers meaningful efficiency improvements while remaining affordable, competitors may reconsider abandoning combustion research altogether. The automotive industry has experienced similar moments before. Technologies once dismissed as outdated have returned stronger after significant engineering breakthroughs. Automatic transmissions replaced manuals in many markets. Turbocharging evolved from unreliable performance hardware into mainstream efficiency technology. Hybrid systems transformed from niche experiments into industry standards. Combustion engines themselves have continuously evolved for more than a century. Mazda believes that evolution isn't finished yet. The company's broader manufacturing strategy also supports this engine program. Rather than building entirely separate production lines for every powertrain, Mazda is creating flexible manufacturing capable of assembling gasoline, hybrid, plug-in hybrid, and electric vehicles with greater efficiency. This reduces production costs while allowing faster adaptation to changing customer demand. If one market rapidly shifts toward electrification while another continues favoring hybrids, Mazda can respond without massive factory overhauls. That flexibility could become a significant competitive advantage during the industry's transition period. Consumers may ultimately benefit the most. Instead of forcing every buyer into a single technology, Mazda offers choices based on individual needs. Someone living in a city with reliable charging infrastructure may choose an EV. A rural driver covering long distances may prefer a hybrid powered by Skyactiv-Z. Another customer may prioritize affordability and proven reliability. Mazda aims to serve each of them. Perhaps that's why the company's newest engine has attracted so much attention. It's not merely another power plant. It represents an alternative vision for the future of transportation. Rather than viewing electrification and combustion as opposing forces, Mazda sees them as complementary technologies working together. Whether Skyactiv-Z becomes one of the defining engines of the decade remains to be seen. But one thing is already clear. In an industry where many companies are following similar paths, Mazda has once again chosen to challenge conventional thinking. By pushing the limits of combustion efficiency while embracing electrification where it makes sense, the company has reminded the automotive world that innovation doesn't always come from abandoning the past. Sometimes, it comes from perfecting it.